Good morning, students. Welcome to my channel Chemical Crystal Palace. Today's topic of discussion will be valency and how to write chemical formula. Compounds like MgCl2 or H2S, we wonder from where this 2 came or why the formula is not Mg2Cl or HS2. Yes or not? This problem can be solved by the concept of valency. So how do we define valency? Valency can be defined as the combining capacity of an atom of an element with other atoms either by donating electrons or accepting electrons or by sharing electrons. Okay, the valency, this thing is called the valency of the particular element. What is it? The combining capacity of an atom of an element with other atoms either by donating electrons completely or by accepting electrons or by sharing electrons. This concept is called the valency of the particular atom of an element. Okay, so we know that in metals, in the periodic table, we have metals on the left hand side, that is group 1a and group 2a. Group 1a is called the alkaline metals or the alkali metals, and group 2a are called alkaline earth metals. The metals of group 1a, that is the alkali metals, donate 1 electron, and the metals of group 2a donate 2 electrons to gain stability. For example, if we take sodium with atomic number 11, the electronic configuration is 2, 8, 1. So in the last shell or in the valence shell, it has 1 electron, so it can easily give away 1 electron and become sodium positive, 1 positive, to gain stability to its nearest noble gas, that is neon. Also, by taking example of magnesium, that is an element of group 2a, the atomic number is 12, we can write the electronic configuration is 2, 8, 2. It can also donate 2 electrons, as there are 2 electrons present in the valence shell. It can donate 2 electrons and become magnesium 2 positive very easily to become stable. We know now that in case of non-metals, what they do is they accept electrons, non-metals accept electrons to gain stability. That is the elements of group 4a or 14, group 5a or 15, group 6a or 16, and 7a or 17 accept electrons to gain stability. Okay, so we take example of an element from group 4a, that is carbon with atomic number 6, electronic configuration is 2, 4. So as there are 4 electrons present in the last shell of carbon, so obviously it cannot donate away its 4 electrons, it has to accept 4 electrons to gain stability. So after it accepts 4 electrons, that is plus 4 electrons, it becomes carbon 4 minus. Why minus charge? 4 electrons are getting added in the last shell of carbon, so it becomes 4 negative. Next we have an example of from 5a group, that is of nitrogen, atomic number 7, electronic configuration 2, 5. So to gain stability, that is to have 8 electrons in its last shell, it has to accept 3 electrons, that is plus 3 electrons. It will become in 3 negative, because 3 electrons are getting added to gain stability. In case of another example, we take from 5A group, that is from period 3 of phosphorus. Phosphorus atomic number is 15. The electronic configuration is 2, 8, 5. So here also, to become 8, it has to accept 3 more electrons. So it becomes P3 minus. Next, we take example from group 6A or 16. We have, this was from 5A. This is from 4A. Now we have from 6A. Example we have is of our oxygen. Oxygen atomic number 8 we have, that is 2, 6. So to gain stability, it just has to accept 2 more electrons to become 8 electrons in its last shell. So it becomes O2 negative. So we see here that whenever electrons are getting added up, the charge becomes negative. Here in case of metals, we saw as the metals lost electrons, the charge became positive because the number of the electrons was getting decreased and the number of the protons remained same. So the charge became plus. But in case of non-metals, we saw that the number of protons remained same, but the number of the electrons kept on increasing. As the charge of electron is negative, so the negative sign is used. Another example of group 6A from period 3 we have is sulfur with atomic number 16, 2, 8, 6. Here also it has to accept 2 electrons to become a stable molecule. Okay, so the valency is 2 minus. Now we take example from our group 7A. This was from group 6. Now from group 7 we have is fluorine with atomic number 9, 2, 7. It just has to accept 1 electron. As already 7 electrons are there, it cannot give away 7 electrons, right? It has to accept only 1 electron to gain stability, which is very simple. So it becomes F minus. You can write 1 minus also, just minus also. And another one we have example is from your period 3 group 7 is of chlorine is 17 atomic number 2, 8, 7. So we have, it can accept only 1 electron to gain stability. It becomes Cl minus. So we see that in case of group 4A, the valency was 4 minus. In case of group 5A, the valency was 3 minus. In case of group 6A, the valency was 2 minus. And in case of group 7A, that is group 7, we have the valency to be 1 negative. Okay. So in metals of like sodium, we have the charge plus, potassium also plus, then lithium also plus. These kind of ions in which the charge is plus 1, such ions are known as univalent ions or cations. Okay. What is the meaning of uni? Uni means 1, valent means valency, and cations means the ions which possess positive charge are called cations. So now we have in case of non-metals that we saw was fluoride, chloride, bromide, iodide. These are all non-metals and they have a negative charge, that is 1 negative charge. These are also called univalent anions. What is the meaning of anions? The ions possessing negative charge are called anions. The ions which possess negative charge are called anions. Now the next part is we take of a divalent cation. Example is Mg2 plus, calcium 2 plus, or zinc 2 plus. These are all called divalent ions or divalent cations. The example of non-metals which we can take is sulfur, then O2 negative. All these are called divalent ions or divalent anions. Okay. So in case of aluminium, we have Al3 plus, aluminium, then boron 3 plus. These are called trivalent cations or ions. And in case of negative ions, we have N3 minus, P3 minus. This is nitride and phosphide. These are called trivalent anions or simply ions. We know that in a chemical reaction, the electrons from the last shell of an atom take part in the chemical reaction. So we saw in sodium, the atomic number is 11. It was 2, 8, 1. The electron from the last shell was lost and it became Na plus 1. But there are few examples of some metals which show variable valency. Like in copper, we have copper plus 1, copper 2 plus. Now metals like silver, gold also show variable valency. From where the concept of variable valency came was, we know that atoms lose electrons from their last shell, but atoms like this silver, gold, copper, mercury, tin, lead, etc. lose electrons from the last shell also. That is, if we draw, this is the last shell, they lose electron from this last shell, and also after losing electron from the last shell, they lose electrons from this second last shell also. This is the second last shell. This second last shell is also called the penultimate shell. So when they lose electrons from the penultimate shell, they show the phenomenon of variable valency. Even iron shows variable valency of Fe2 plus and Fe3 plus. These were few examples of variable valency. Next we come to the concept of radicals. How do we define radicals? Is a radical is a group of atoms of elements that behaves like a single unit or entity. And shows a particular valency. For example, we take Azov. Common example is ammonium, NH4 plus. Here we see that two types of atoms are present, that is nitrogen and hydrogen, but the total valency combination of this nitrogen and 4 atoms of hydrogen we have is plus 1. Same is in the case of hydroxyl, the valency is 1 negative. In case of sulfate, SO4 di negative. These are the examples of radicals. So we define it as a radical is a group of atoms of elements. It is a group of atoms. Here 1 atom and here 4 atoms are present. That behaves like a single unit. It behaves as a single unit. This nitrogen will not show a separate valency and this hydrogen will never show a separate valency. It will form a unit valency that is of 1. And as it behaves is a single entity. The next topic is atomicity. So how do we define it? As the number of atoms of an element present in a molecule is called its atomicity. Like when we take example of hydrogen gas. How many atoms of hydrogen are present? One hydrogen and one hydrogen. There are two atoms of hydrogen, so the atomicity will be 2. In case of, again, ammonia, we have how many atoms of nitrogen? 1 atom and 3 atoms of hydrogen. So the atomicity will be 4. In case of your sulfate, we have 1 atom of sulfur and 4 atoms of oxygen. So the atomicity will be 5. This is basically the concept of atomicity. So in the first part, that is part 1 of today's lecture, we learned about valency, that is about the metals and non-metals. I explained by giving examples from group 1A, 2A, 3A, 4A, 5A, 6A and 7A of the periodic table. Then we read about the variable valency, radicals and atomicity. I hope you guys are clear with the concept, and if you have any doubts, then you can ask in the comment section below. And next, in the part 2 of the video, I'll be providing you people with a valency chart, then rules for writing chemical formula, and how do we write a correct chemical formula. This will be taught in part 2 of the lecture, which I'll be uploading very soon. So stay tuned for the rest of the videos. Thank you.